Hello everyone, this is Tom Morley and this is video number 8 in the Space Blasters 84 tutorial. In this video we are going to implement the actual ship for the scene. So let's get started. Let's open up Godot. Let's open up our Space Blasters 84 and we're going to need a folder with the ship image in it. So let's go ahead and just open up a browser and we'll go to the Space Blasters 84 main folder. We'll create a new folder and we're just going to call it ship. And in this folder we'll create an image folder. And we need to put the ship image in that folder. So let's back up to the source files. And we'll go into source and we'll go to the ship folder, and that's where I have my Alien 2 PNG. And again, I can't say enough about the guy that creates this artwork. He's known as Millionth Vector, and there's the web address where you can find a bunch of different 2D images that he created. He's pretty awesome. So let's copy this, go back up to the main Space Blasters folder, go into ship, go into image, and we'll paste it in there so that we have it. So now we're ready to go here. So we can minimize this. Let's click on 2D here. In our new scene, let's create a base node here, and it's just going to be node. We'll rename that to ship root. And what we need to do is create a physics body, because we're going to be using physics for the collisions in this particular game. And I want to be able to control all aspects of this particular physics body. So I'm going to use a kinematic body. That's when I'm going to write all the code for the behavior of this particular item. So we will make sure ship root is selected. We'll go into the 2D section of our nodes and we'll look for kinematic body, and it is right here. We'll double click on that to add it, and we're going to just rename this to kinematic body underscore ship, just so we know what it is. This kinematic body is not going to be visible unless we create some type of sprite or image for it. So we'll make sure that the kinematic body is selected and we'll add a sprite node. And again, this is in the blue 2D section. Just double click on sprite. And we also want to be able to receive notifications when something collides with the ship. So we need to add some type of collision shape. So again, make sure the kinematic body is selected. And we're going to add a collision shape 2D, which is right here. Double click and add that. Here I'm going to start my monitor keys here so that you can see what I'm typing as I type it in here. And I'm going to scroll down so that we can see the viewport area, or the game area here. Now we want to be able to see the ship, so let's click on the sprite and add that sprite to our scene. With sprite selected, go over to your inspector, and where it says texture, we're going to load a texture, and we're going to go to our ship folder in the image folder where we copied the actual ship PNG, and double click and add it, and now it has been added to our scene. I'm going to scroll in here just a bit with my mouse wheel so that we can see what we're doing here. And the next thing I want to do is I want to define the area around the ship that things will collide with. So we'll go to the collision shape 2D node. We'll go over to shape and we'll hit the drop down box, and we're going to use basically a capsule shape for the collision area for the ship. So you'll see that it created it. And you may be tempted to grab these corners and adjust the size of the collision area here, but you don't do that in Godot. You click on this little arrow here, which brings you to the capsule shape 2D radius and height. And this is where you will basically adjust the different width and height of your collision area. So I've already done this. I know that the radius will be in the neighborhood of 55 and the height will be in the neighborhood of 114. And that basically covers the whole ship for us, so that if anything comes near the ship, it'll collide with this area here. Okay, so we've got the ship. We've defined the collision area. Now we need to implement some behavior for the ship itself. So let's select the kinematic body 2D and let's create a new script. So we'll select create new script with the icon here, and we will make sure the path is going to the ship folder, and we're just going to call this ship.gd for a new script. Click save and create, and it gives us the default setup that we're used to. So the ship in our scene needs to be aware of a couple of things, right? It needs to know at least know when the game is running. So let's create some variables here. Let's wipe these out. Let's create a variable, just game running. And of course, in the beginning, we're just going to say it's false. The game is not running. Now, in some of the games that you create in Godot, you just need to know when the ship goes left, right, up, and down. But I want more behavior than that. I'm going to put thrusters on my ship, so I want to have some acceleration behavior and some deceleration behavior. So we need to define a few variables so that we can make that happen. So we'll create a variable called max speed, and we'll set that max speed, and I've already played around here, and you can change the values to what you like here, but I'm setting the max speed at 700 pixels. We also need to have some way of defining our acceleration. So our acceleration ACC will be 20 pixels. We also need a way to track the current speed of our kinematic. So we're just going to create a variable here called kin speed, and we're going to set that equal to a vector2. And we're going to do that because we need speed in both the X and Y axis. So this is going to give us a great way to implement that. Okay, and I think that's really all we need. Now we are going to be detecting collisions here, so we need to use the fix process. So we're going to set the fix process to true because we want to use it. And I like seeing these in here. I don't think it makes any difference, but I just like to see it. So we need to create the fix function process. So we need to put it in here, function fix process with our delta. And this is where we're going to put in the behavior that we want for the ship in order to make it move. The first thing we need to do is see if the game is running, right? So if the game is running, we want to do some stuff. Let's just put pass in here for now. And if it's not running, we also need to change what's going on with the ship as well. So we're going to put an else in here. for now, we'll just put pass, just so that it isn't screaming at us. Okay, so when the game first starts up, or when we first load this ship into our scene, we want it to be at a certain location. So we're going to put that location in our ready function. We're going to say that we want to use a fixed process, and we're going to put the ship at a certain location. So we need to get node, and we're always going to be moving the kinematic body itself. So we're going to basically get node, and we want to get ourselves. So it's just going to be the dot right there. And we want to move that kinematic body to a certain location on the screen. So we're going to use the move to function. And it expects a vector 2, so we'll give it to it, vector 2. And where do we want to place our ship on the screen in X and Y coordinates? So we want to basically put it at half of our 1080, right? Our screen is 1080 by 1920, so we want it to be in the middle of the screen. So half of 1080 will be 540, and the Y location, I've already played around with this. I want it just underneath the menu area when we first run the game. So 1450 will be the Y location where we want the ship to basically be created. So let's go ahead and save this scene. Again, go into the ship, and this will just be called ship scene. So now that we saved it, let's go ahead and run it. And what we should see is we should see the screen pop up, and our kinematic body, which was originally at 0.0, has been moved to the 540 by 1450. So this is exactly what we want. Now we need to get the ship to move a little bit. So let's talk about how to implement that part of the game. The first thing we want to do is we want to check to make sure that we're pressing an arrow key, either up, down, left, or right. So we need to check for something. If the game is running, we need to check to see, and I'm just going to copy and paste some code in here so you aren't watching me basically type things in. This should speed things up a little bit. So if input action pressed up, or the input action is down, or it's left, or it's right. So I'm checking to see if I've pressed any key, up, down, left, or right. And if I have, I want to start defining the movement of my ship. The first thing that I'm going to define here, if I can select it all, there you go. I'm going to paste it in here so that, again, save a little bit of time. So if any of my up, down, left, right keys are being pressed, well, then I need to start checking to see which keys are actually pressed. So the first thing that we want to check for is if the up key is pressed, we want to check our current kinematic speed in the Y direction. And seeing how we're using the up key, we're going to be going in the negative direction. So we want to make sure that the kinematic speed stays underneath our negative 700 max speed. So if we are, then we want to take the kinematic speed and say the kinematic speed equals the kinematic speed plus a vector 2 that's going to be 0 in the X direction, right? Because we're using the up key, which is in the Y direction. So we don't want to change that, but we do want to add to the acceleration of the current kinematic speed. So let's say the kinematic speed was 0. then it would be, after it goes through this conditional statement or conditional code, it would be 0. We'd be saying the speed is going to be 0 in the x direction, and it's going to be -20 in the y direction. So it'll start moving up on the y-axis. So that's if we just wanted to move in the y direction using the up key. But it's not going to actually move the kinematic body until we assign this kinematic speed to some function that moves the kinematic body. And the kinematic body has a function called move, and that's what we're going to be using. Move. And it expects a vector too, right? So we're just going to say move at the current kinematic speed. So now you can see that on the kinematic body here, I'm asking it to move in the x direction 0, in the y direction -20 the first time I go through this if my up key is pressed. So why am I using move here, and I used move to for my kinematic body up here in the ready function? The move to function is going to move the kinematic body directly to a location, XY location on your screen, like this. We say move to 540 by 1450. It takes the ship and it will move it to that XY location if it can. The move function is basically saying I want you to move your kinematic body in a certain direction. So in this case, the x value is 0 and the y value will be -20, right? That's our variable setting up here. So I'm asking it to move in that direction, not move directly to it. So if it's able to move in that direction, it will. So now I expect if I play this and I press the up key, the ship will start moving in the y direction with some acceleration moving up. But the first thing we need to do, let's just for now just change the game running to true so that we can actually get into this code here. So the game running is true. We'll start to go through this. We'll change that later. And now if I play this, my ship won't move if I hit my left key, my right key, my down key, but if I hit the up key, I expect to see it start accelerating super fast up to the top. Now that's not the behavior I want. I want it to basically move 700 pixels per second. So I need to multiply my kinematic speed, which is 700 pixels, times my delta, so that I can get a smooth 700 pixels a second as my game is playing. So now let's play it. And you'll see when I press the up key, it just starts moving. And if I press it and hold it down, it will start moving up. And the cool thing about this is I'm basically clamping it, saying that I never want it to go faster than 700 pixels a second. Yet when I press and hold the key down, I want it to accelerate 20 pixels a second until it gets to that 700 max speed. And now we're just going to apply that same behavior to the other keys as well. So now we want to add the down one. Okay, so I'm just going to copy and paste this in here so you don't have to watch me continue to write the code here. Again, this is kind of shorthand for doing the exact same thing here as kinematic speed equals kinematic speed plus vector. You can use the plus equals once you get familiar with the concepts. I suggest you use plus equals rather than the longhand version here. But here we are. The down behavior is if the down key is being pressed, I want to check the current kinematic speed. If it's less than the max speed, then I'm just going to add some acceleration to it in the down direction. So now if I play this, let me just kind of put a couple in between there. Now if I play this, I should be able to use the up key to make it move up and the down key to make it move down. And you can see that I'm applying that acceleration and deceleration just by every time I go through that fixed process. I'm only adding 20, suggesting that it adds 20 to the acceleration of the ship in the direction that I'm using the arrow keys. So that's perfect. That's exactly what I wanted to do. Now we just need to add the left and right. So let's go ahead and add the left and right, and I'm going to grab the left and right at the same time, because by now you should kind of understand what's going on here. So I'm just going to paste that in here, and again, this is the shorthand version, but if you want to see it the longhand way, it'll be kinematic speed plus vector 2, and same thing with this. You can do it either way. It's just a little bit easier to understand when you first start coding to see it the longhand way. So here's my left behavior. I'm going to check the current speed, make sure that the current speed is not exceeding our max speed in the negative direction. If it isn't, then I'm going to accelerate it in that direction. Same thing with the right speed. So now if I play it, I've got all the behavior for my arrow keys. I should be able to go up, down, left, and right. But you'll see, see the ship goes off the screen. But pretty cool. I've got the behavior that I'm expecting for the ship itself. So that's pretty cool so far. All right. So that's if I'm pressing a key. But what if I'm not pressing any key whatsoever? The behavior, let me start this up again. The behavior is if I just press the up key and let it go, you're going to see the ship just continue to go up until it hits the edge of the screen and goes off. Well, I want a way to basically have it decelerate if I'm not pressing any of my keys. So that's why I have this check here to see if I'm pressing any left, right, up, or down keys. If I'm not, so and this is where a function in the Godot game engine is going to help us out. There's a lerp function that we can use to basically give us the behavior that we want to slow the ship down over time. So I'm just going to again paste that in here so that you don't have to watch me copy and paste everything. And let me back it up and I'll explain what it is here. So if I'm not pressing any keys, I want the ship to start slowing down. So I need to change this kinematic speed over time. So the kinematic speed in the x direction, I want that to equal the result of the lerp function. And what does the lerp function do for me? Well, it's going to take two float values and basically change that value over time by a preset amount. So I'm going to look at the current speed of my ship, the kinematic speed in the x direction, and I want it to go from its current speed to 0. And I want it to do that in increments of 0.03 every time we go through the set process function. Okay, so I need to create that code for the x and the y direction. So now if I play this, I expect to see the ship slow down once I stop pressing a key. So I press the up key and I let go, and that's the exact behavior that I'm looking for. So now my ship will go up, down, left, right, and it will slow down based on the lerp function settings when I'm not pressing a key. This is exactly what I'm looking for, because I'm going to be adding thrusters to the left, right, upper portions and lower portions of this ship to kind of make it feel like you're in outer space and you're actually using your thrusters to manipulate the ship around. So that's pretty cool. The next thing we need to do is to keep the ship from going off the screen, right? So we need to do that some way. There's a couple of different ways we could do that. In the past, I've created some static bodies and I put them around the screen area to basically collide with and keep the ship in the screen. But I think that that's really unnecessary. All we need to do is just make sure that the ship stays within a certain boundary, and that boundary will be the viewport that we're running the game in. So the ship itself, I'm going to run it again. here. The ship itself, we know that when we first put the ship on in the game area, the 0.0 location for our ship is right in the middle of the ship. So the ship has some padding, and by trial and error, I know basically what that padding is, how many pixels it is from the center of the ship to the outer regions of the upper and left, right, and lower portions of the ship. So we need to create some variables that represent the padding of our ship. So let's go ahead and do that up here. We need to create a variable for the padding called ship pad x, and I know by trial and error that padding is 58 pixels. We also need a variable for the y direction, so ship pad y, and that equals 120. Again, I did this just basically by trial and error, but I know that the padding is 58 and 120. You can probably find that out using a graphics program if you wanted to. But yeah, so basically at this point I want to make sure that I don't go beyond the bounds of my viewport area with the ship. So I need to write some code in here to basically keep it in that area. And I'm going to copy all of this at once and paste it in here, and then I'm going to walk through it so that you understand what's going on here. So I'm going to say if and get the current position. I'm getting the current position of my kinematic body. If the current position in the x direction is less than the ship padding, then I need to do a few things. So if the position in the x direction is 58, that is, I'm all the way to the left hand portion of the screen, and normally if I didn't have padding, I'd say if the position is less than 0, then I want it to stay at 0. But in this case I need the padding as well, so I'm going to say if it hits 58, it doesn't go fully to the left hand portion of the screen, but the sprite is still on the screen by using the ship padding. I want it to stay at 58 in the x position of the screen. So if the position is less than 58, I need to reduce my speed of my kinematic. I don't want it to have any speed whatsoever. I want it to stop. So my kinematic speed in the x direction is going to equal 0. And then I want to move the kinematic body, because at this point it's less than 58, right? So I want to move it back to 58. So I'm going to say move to, and I'm going to use a vector 2 to define the xy coordinates and the ship padding, right? So I'm saying I'm going to move my kinematic body to x position 58 and y position wherever it is currently located. So I'm going to get the position of my kinematic body, and if no matter where it is on the y direction, and I'm going to say stay at that y direction. So really the only thing I'm doing is ensuring that for this if statement that the ship never goes less than in the x direction to less than 58, but it can remain in the y direction wherever it currently is located. And I'm going to use that same behavior for all of the rest of the directions. So that's the minimum value, right? This if statement here is the minimum value that I want to check for, and then I need a maximum value. I never want it to go past the 1080 pixels of my width of my game area, right? So how do I know? I suppose I could hard code that in there if I wanted to, but there's a method in Godot that allows you to get the size in pixels of your viewport, and that's the get viewport dot get rectangle dot size, and in this case I want to know the size in the x direction, right? So this right here, this function call is going to return, in this case because we know that the viewport screen width is 1080, this would return 1080 pixels, right? but we will always want to remember the ship padding. So we need to get the position of the kinematic body and make sure that it never goes past the width of the screen minus our ship padding. Okay, so if it does go past that, again, we need to set the kinematic speed to 0 because we don't want it to move any more in the X direction, and we want to slide it back at this point here. It's past the width of the viewport screen, so we want to move it back so that it stays inside the viewport area. So we're going to move 2, and again the vector 2 is going to allow us to put in an XY location. So we're going to tell it to get the viewport size minus the ship padding, and we want to place the ship back into the screen area. And again, we don't want to mess with the Y because we didn't check for the Y. So whatever the position of the Y currently was, that's what it's going to be here when we move it. So, and the same thing for the Y direction. We're going to check to make sure that the Y direction is never less than the ship padding. If it is less than, we're going to set the speed to 0, and we're going to move it back into the screen area again. Same thing with the last one. So now if I run this, it should never go past the area of the width and height of our screen. So let's go ahead and try that. We're going to press up, left and right, and you'll see something kind of strange. Okay, my ship is now restricted to this small area here. I'm pressing the right key and I expect it to go to the full width of the viewport. So why is it not doing that, as well as the height of the viewport, because it's stopping right here? Well, it's doing that because I put the wrong settings in the project when I created the very first scene in this project. So we needed to fix that. So to fix this behavior, we need to go into scene, we need to go to project settings, and we need to scroll down to where we defined the stretch mode. Okay, remember I wanted to be able to stretch this and have the image go all the way across my screen while I was working on it on my computer. But we don't want the stretch mode to be in 2D, we need it to be in viewport mode. So if you change the stretch mode to viewport, and now if we play it, we should get the behavior we're expecting. The ship will go up to the top, stop, all the way to the left of the viewport, the right of the viewport, up and down, and when we let go of the key, we get the deceleration we're expecting. So this is perfect. You know, we have all the behavior we need in the ship, with the exception of the ship knowing when the game begins and the game ends, right? Because when the game ends, I want that ship to basically park itself underneath the high score menu. As well as when I start the game, I need that ship to always be at the parked location. So let's put that behavior into the script as well. Okay, so we need to change our game running to false, because when the game first starts up, the game will not be running. So we need to change some things in here in the else statement. We need to park the kinematic body 2D, so we need to get the node. And we want to move it to. Again, we're using move to because we want to move the kinematic body to a specific location in the XY coordinates. So we use move to when we want to move it to a specific XY location. So it expects a vector 2. We'll put it in. We are going to use half the width of our game play area, which is 540, and the park location was 1450, I believe, in the Y direction. So we're going to park the kinematic body if the game is not running. We need to check for input. Let's close that out first, and then we're going to check for input. Is action pressed? And we want to know if anybody pressed the enter key. So that's the UI accept in our map. So if somebody presses the enter key, then we want to start the game. So the game running at this point is going to be true. So if we press the enter key, the game starts to run, then we start moving our ship and it will have all this behavior. But we need a way in the code here to basically end the game. So let's put that code in here as well. Let's say here, if input map or input dot is action pressed, and we want to check for the escape key at this point, which is the UI cancel in our map. If somebody wants us to quit the game, well, we don't know the state of the speed of our kinematic body, right? So we want to make sure that the kinematic body is not moving at all. So we need to reduce the kinematic speed to 0.0 in the X and Y coordinates. So let's get the speed of our kinematic body, and let's make sure that it's a speed of vector 2 0.0. So we're telling it basically stop and don't move anymore. And we want to set the game running to false. So when we set the game running to false, of course, it's going to park the ship just below the menu area. So then we should have the behavior we're looking for. Let's click play and find out. So in the very beginning, we should be able to press the arrow keys and nothing should happen. And that's because we haven't started the game. You press the enter key and look at that, the ship starts to move and it has all the behavior, acceleration, deceleration we expected before. And if you hit the escape key while the ship is moving, it should automatically just stop moving and park itself down underneath the high score menu. So we have all the behavior that we're looking for. We are done with the ship scene for now. Let's add it to the main node so that we can see it all working together. So let's save this scene and let's open our main scene in SB84 main. Let's make sure the SB84 root is selected. Let's hit the plus key to add our ship scene to the root. And it looks like I've already done that one, so I'm going to, let me just delete both of these. I must have forgot to delete those. And again, make sure SB84 root is selected. Let's add that ship scene in. And now if we press play, okay, it starts up. We hit the arrow keys and nothing happens. If we press the space key, then the game starts up, the ship starts to move, the behavior is what we expect. We hit the escape key and it should end the game and park the ship underneath the high score menu, and it does that. So congratulations, you've completed the spaceship scene part of Space Blasters 84. And next up is the lasers so that we can start shooting lasers out of the ship. So stick with me, it's coming up.